Okay, well, continue on here and see if we can pass on a little more info. Since the last time, on the last video, I was showing how to make this little voltmeter, high voltage voltmeter. And since then, I have found a different meter that's still 1 milliamp full scale, but the scale reads from 0 to 3. And on the old one, you can see that there, it was calibrated from 0 to 1. And to make the numbers make sense, we had to call the 1 well, it would be 10, but we used a 1 meg resistor, so the full scale would be 5,000 volts. Well, that meant that 3,000 would be on the 6, and really hard to read when you're looking for 2,700 volts. So with this one coming up to 3, what I made a change is in the circuit for the resistors, and I went ahead and even after rethinking what I did is was able to come up with some 2-watt resistors. And what I did is took 2 half-watts, get them where you can see them, 2 half-watt resistors, paralleled them, that makes 500K. Take a second pair, parallel them, there's 500K. But when you connect them in series, you would call that one resistor. That's 1 meg, but now you have 2 watts of dissipation. Just that easy. And I had a couple hundred of these things, so instead of just hunting on eBay to see if I could find 1 meg 2-watt resistors, I went ahead and made it that way. So anyhow, what I did was made up a divider that had 3 megs total resistance. So with 1 milliamp, the meter would read full scale at 3,000 volts. So that put my 2,700 volts that you're going to get off of a microwave oven transformer right at the tip, right there, just below the 3. So it's easier to see when you reduce power or whatever voltage you have, and you're not going to be seeing anything over 3. At least I haven't yet. I haven't found a microwave oven transformer that went over 3,000 volts. They all average right in and around 2,700. Okay, now move on to working with a transformer. This video will be about how to come up with the voltage you want from a microwave oven transformer, and I'll show several other examples of transformers. But the idea here is you got to dewind. This looks destructive, but you got to take a drill, start out with a small bit, and then you can just work through, and you're going to go right between the laminations and the windings. This is going to take a little bit of, you might have to try this on 1 or 2 of them before you get it to where it'll work. But like that. You're just going to keep working it until you can get a hacksaw blade to slide through there. Okay, now what this is for is so that you can reach and grab wire. I'll show you this in just a second here. You're going to pull layers of wire off. What you're wanting to do is dewind this transformer down to a level to where it'll give less voltage. And you just keep working at it to get into your windings. You're going to have to cut them a little bit. So I'm using a carpet knife. Get this up maybe where you can see it here. you want to cut and cut away from, in other words, don't cut the other direction to where you're going to be hitting the primary. You just want the secondary. So you're going to take and just go make it fairly deep, because you don't need to worry, you're going to be taking quite a bit of wire off of here. And then what you'll do, start peeling up wire, and as long as it comes off, this came off because your drill has cut into the first few layers, so you're just going to do this for a while. Keep peeling up the edges until you can't get any more. That'll just come off easy. When you get down to a lower layer and you've gotten away from the damaged windings that are on the top and the bottom, I'm going to cut some more of this a little bit. Okay. Now that and see what's still coming off. So we'll cut a little more. Make myself some room. I gotta go the other direction for just a second. Now when you're coming down with your knife, don't cut too far down on the sides. You want to just stay on this face and come across. Basically what you're trying to do is take the first, third, second, third layer. Maybe it'll take 2 or 3 layers at a time that you're going to cut through, and that's okay. What you'll do is keep dewinding this until you've started running out of wire that you can pull off. In other words, you'll go around the transformer, and when you come to this cut, it'll break off. Well, you keep going until you've cleaned that up and you're down to where you got maybe 1 or 2 wires that you can grab. That's when you start using your hacksaw blade, and you tuck that wire up through the hole there, and you'll pull it back through. I don't know see if I can get that far enough down here where we can get past the drill damage, and I can show you how that works. I might have to stop the camera here for a bit and then get it to that point. Come back later to show you. But let's see what we can do here. Okay, now the thing I didn't explain, I guess, at first here, the reason of doing this is if you want to use tubes like a 4CX250 or other ceramic tubes, 2,700 volts will damage them. So what you're wanting to do is peel off enough windings to where that when you're done, you end up with around 2,000, maybe 2,200 volts is about right. So that's the idea, that what we're behind the reason we're doing this. I can show you one other transformer just quickly. This one I used, and you can see I took a lot of wire off. And I've added some other wires in here, and I've made a couple taps. This is a tap for screen voltage. This is my start. This is the wire that was originally hooked to the little ground tab. And my other free wire, the outside end, is the other end of that. So when you hook to your diodes, you'd have this one, and you'd connect to this center wire. In other words, this is the start and the finish. And like I say, I tapped off for screen voltage. This transformer, I took off enough wire where it left me with about 900 volts. 900 volts was perfect for a pair of 26 HU5s or tubes like 6 KD6s, something like that. But this amplifier was where I used this one was in a amp that had 4 26 HU5s, and was coming out with a little over 400 watts out of those 4 tubes. Filament voltage, since they're 26 volt, I wound a filament in here. That's what part of this is. And then continued on. In other words, the start of that wire was just grounded. So at this point was my 26 volts. Continued on because I had some 48 volt relays, and I used this to key the relays. And the bias, I just come off the 26 volts, sent it through a voltage doubler, and that gave me bias voltage for the 26 HU5 tubes. But you could keep on going and remove even more if, say, you needed a transformer that gave you 600 volts, or say an audio amplifier and you needed 400 volts. Some of the older tubes didn't take or need that much voltage. So you could just keep removing this until you came to the point to where you had the correct amount of voltage you needed. And then at that point, stop, dress your wires up, and everything's good to go. You don't need to do anything to the primary. You just leave it the way it was. One word of caution on this one. I made the mistake of not paying attention when I was drilling through. I had turned it around and I had gone through the opposite side, and I didn't notice that the angle on my drill had gotten off a little bit. So inadvertently I damaged the primary. So a thought here would be to leave your hysteresis slugs, the blocks, the shunts, leave them in until you have this done. That way, if your drill can come up against those shunts and you won't slip over into the primary windings. Then when you're all done with this and you have everything ready, then your way will be clear to knock the shunts out. You'll have actually more access, easier access to them. There's still a lot of paper and junk in here. I haven't cleaned that all out. I may have damaged the windings. I'll check this later, but just for the sake of being able to show how to start on this process, I just went ahead and used this transformer to show. Okay, I'm going to come back in a minute. I'll shut this camera off. I'm going to clean this up, take some more wire off, and I'll show you how that hacksaw blade works to remove the wire. Okay, here we are a couple hours later. I've got it pretty much cleaned up. I have a little damage to clean up right here. I don't know if you can see. It's where the box cutter knife scratched one layer underneath. That's going to be normal. If you end up with a wire that looks like it might be coming from the next layer down, stop and just leave that one alone until you get to it, because that's more than likely where you're headed when you get the layers down. I see I've got one layer, and that should clean that up. But this is, when you get this down to this level, it's just a matter of poking the wire through the hole in the blade, pulling it through, and you just keep going around and around. You can trim it, cut it off when it gets too long. Anyhow, you'll do this until you've finally peeled all this bad layer away. And when you get down to where you can get continuity between the wire and your ground contact, you've got it. Then you can hook it up to your test full wave bridge and test your voltage at that point. See if you've got it. See if you've taken off enough turns so that you can get around 2000, 2200, 2200 volts. Okay, what I will do in probably the next video, I will show how to put together a stack of condensers and a set of diodes. You'll use it for your power supply, but you can use it as a test setup to begin with. A couple other things I'd like to talk about on these transformers. I have seen just recently, I've hit a few of these, that the wire is made of aluminum. If you run up on one of these, try your best not to disturb this wire. And trying to do the drill thing to remove the turns isn't going to work, because you'll never be able to reconnect to that aluminum. It just won't work. It's fragile, it'll break off. The best thing to do with these transformers, just simply take the shunts out and leave it as is. What you can do with these is you take two of them and you treat it like a center tapped full wave bridge transformer, where you've got both 110 windings, primaries. They're hooked in phase, or hooked correctly, to where you have a start and finish opposite. And you take two of these transformers, and a little simple circuit makes it so you can make it step start, or soft start as they call it. And another way it's useful to them, you can use them, since they're 220 volt transformers, secondaries, you can use these on 240. Real simple, just a little relay arrangement, and I'll get to that in a later video to show you how to use these. That way you'd have full 2700 volts, two transformers, you'd be able to run them on 220, and they'd be good for a pair of 3500Zs, 4400s, what have you, at a full 2700 volts on the transformer. But yeah, I don't know if the camera can pick it up, but even the primary is aluminum. You can see that shiny silver color there compared to copper. See? And you just can't solder to aluminum. They've got some special way of plating copper on the aluminum, and then they solder to it. But that's pretty high-tech stuff. It's just easier to leave them alone and use them as 2700 volt transformers. Another thing is, when you're looking around to find voltages, these old style wall warts make good sources of small transformers. Like this one, This one came out of some kind of a old computer power supply. It was a Coleco, was the brand name on it, on the box. And it's even got a couple little 2 amp fuses. And this is a center tap transformer, and it was 24 volt. So they were using probably full wave bridge and using the center tap also, and then getting 12 volts for their power supply. This one, 24 volt, it will supply 400 milliamps. And what you do here is just take a hacksaw blade or something and cut the box off. Switching transformers won't work. Switching wall warts won't work. Number one, they make noise, radio-like static. You look for the ones that have some weight to them. They'll weigh a little bit. This one's almost about 2.5 pounds. And this one would make a good bias supply. On most of the tubes, you only need about 35 milliamps or so at most of bias current, and 24 volts. You could double that voltage if you needed a higher bias, like some of the 6LQ6s, 6KD6s, if you run them class AB1 with not in grounded grid but in grid driven, you would need about 60 volts, and you could get that out of by doubling or tripling the voltage with a diode capacitor doubler. Okay, let's see. I think that's probably about got it. We'll wrap this one up. Let's see, what'll be the next video? Oh, okay, the next video I will assemble these snap-in caps and make a high voltage power supply filter bank out of them. This is what I mean. You put them on a little piece. This is plexiglass, and I'm going to mount them on here, hook them up in series so they get my voltage up. They're only see, these are 330 microfarad at 200 volts a piece, and I usually use about 16 of them to be safe. All electronics is a good spot. I didn't get these from them, but I was just looking around for a source where I could pass on. I think they've got some of them for like 65 cents a piece. So you could make a high voltage stack pretty cheap. A good place for your high voltage diodes would be Mauser Electronics. Buy them by the 100, or you could even find them on eBay. I would use 1N5408s. If you're going to be using like a 2 transformer setup and going with some high current, high voltage, I would buy what they call the 6A10s. They're a diode that will give 6 amps forward, and I think they have like 30 or 40 amp surge, and the peak reverse voltage is 1000 volts. Okay, hope that's been able to pass on a little bit of info there to you. Hope it's been helpful. Alright, thanks for watching. Catch you on the next video.